Hi everyone. We are going to talk about MNIST today. MNIST is a dataset from PyTorch, and so we're gonna kind of walk through what it is to download the MNIST dataset and kind of visualize how to work with a basic dataset in PyTorch. So let's get started. First, we will import some libraries. So we're gonna import Torch. We're gonna import the Torch datasets. It's actually from Torch Vision. We're also going to import the transforms. And so let's also import the data loaders. So we can say torch.utils.data. Um, we're going to import the data loaders. And those are some basic libraries I want to use for now. So after we import our libraries, um, let's start working with importing this data. So in machine learning, we have training data and testing data. Training data is how you train your model with your data. Testing data is how you test that model. So you don't want to train the same data that you're testing with. Because when you test your data, you don't want to use the same data that you trained your model with, or else you don't know if it's really going to work on data that it hasn't seen before. So let's create a training data variable, and we'll load our training data. So PyTorch has a library that you can load the MNIST dataset. And so basically what the MNIST dataset is the MNIST dataset is a list of handwritten digits. And so each of those digits has an image and a label. And so obviously computers can't really understand images as much as it might seem like they do. They actually deal with numbers. And so we have that image as basically a list of numbers. So we've got a few parameters that we need to deal with here. Um, First, we're going to deal with the root parameter. And so that is where we want to load our data. We have to decide if this is a training data or a testing data set. So usually you have to split it on your own, but since this is just a toy data set with PyTorch, they let us just kind of decide if we want the training or the testing. We're going to load both, but since we're getting our train data here, then we'll say we do want to train it. We also have to transform this into a tensor. And so the reason that we need to do that is PyTorch works with tensors. If you're not familiar with tensors, I recommend that you go research that a little bit. It's a really big part of PyTorch. And we do have to download it since we haven't seen this before. And we will also do the same with the testing data. The only difference between these two is in the first one we specify that we want the training data, and here we specify that we want the testing data, so we don't want this to be the training data. And then once we download that data, then we should be able to see it in our directory. So there is our data right there. And if we wanted to call it something else, then we could. I just called it data. That's just kind of convention for this. So after we have our training data and our testing data, let's kind of visualize it a little bit and look at it. So we can see how many training data samples that we have. So we have 60,000 training data samples. That's a decent sized data set, definitely. So that's 60,000 images of handwritten digits. So, and those digits are 0 through 9. And so 60,000 is definitely a decent amount since we only have 10 classes that we're defining. And we have our test data, so it's a little less, but I think that's a pretty solid ratio, 60,000 training data and 10,000 testing data. So the next thing that we have to do is load it into a data loader, and a data loader is something in PyTorch that lets you train your data so that you don't have to train it all at once. You can actually train it in batches. So you need to specify a batch size, and this usually needs to be a power of 2 for optimizations. 64 is a pretty common one, but then again, this is so that we don't have to train all of our data all at once. We can train it in batches. So we'll train 64 images at a time. So I'm going to call it the train loader for the training data. So we imported this a little earlier, and we can put our training data here. We'll specify the batch size of 64, and here we can shuffle it. So if we want to make sure that all of our data isn't like sequential, so if we had a bunch of zeros and then a bunch of ones and then a bunch of twos, it may not be the best to train it like that. So we may want to shuffle it. It adds a little bit of time, but not too much. So I usually recommend shuffling it. So once we have all that loaded, we can kind of take a look at our train loader. We have 938. Now you might be asking yourself where we got that number. Something that we can do is we can say our train data, which we said was 60,000 divided by our batch size, is going to be 937. So we have 938 batches that we're dealing with. So each one of those batches has 64 images. So, like I said, we're not going to be training all of our data all at once. We're going to be training it in batches. So that's where we got 938. All of them have 64 images, and the last one, since we have 0.5, is only going to have 32 images. So let's kind of visualize our data a little bit. So let's add another library here. Let's import matplotlib. And so what we can do with that is we can kind of visualize what our data looks like. So since we loaded all this onto tensors, we're going to be getting a bunch of images that are just a bunch of tensors. So it's just going to be a bunch of decimal floats. And so that's easy for the computer to analyze, but it's not really easy for us to analyze. So we've loaded the data. We have data loaders to separate all of our batches. So we've got a bunch of tensors here. So we've got our train loader here, which is a data loader type. So let's make this a little bit easier for us to visualize. So let's first put this into a list so that we can do some common Python operations on it. This is not the ideal for the computer to understand, but this is going to make it easier for us to understand. So we have our data here, and let's look at our data. So we've got 938 batches. So let's take a look at our first batch. So we have data 0. So we've got a tensor here. Looks like it is a 4-dimensional tensor. And we've got a list of labels here. So these are all the labels that we know these images are with. So we have 64 images here, and we have 64 labels here according to our batch size. So the first one is going to be a 2, the second one's going to be a 4, and so on. So let's look at, let's confirm that we have 64 here. Yeah, we have 64 here. So we had 2 tensors in each. The first one was the images, and the second one was the labels. And in the images one, we have 64. And in the labels, we should also have 64. So let's look at that. We also have 64. So let's look a little bit farther in it. Let's say let's get the shape of this. So um, we've got a 64 batch size. This one means that all of our images are either, each pixel is either going to be a 0 or a 1, or somewhere in between there. So it might be like 0.8. And that depends on how dark is that image. Since this is grayscale, 0 is going to be a really black image, and 1 is going to be like extremely white. So if we have something like 0.5, that means it's like middle ground gray. 0.9 is going to be something like pretty white, but like maybe a little bit of gray. And then we've got a 28 by 28 image. So let's visualize this a little bit. Let's clean this up. We'll keep this here so it's easy to visualize. So we've got this tensor here. Let's take the first batch. Okay, so this is the first image of the first batch. We should have 28 by 28, which is 700 and, let's see, 784 pixels. And each one of those pixels is going to have a value between 0 and 1. So a lot of these have 0, so these are just going to be black. And we have some in the middle here that are a lot more white. So we got 0.99, so those are going to be a lot more white. And so let's see if we can kind of plot this into something that's a little bit easier to show. So we'll just store this into an image variable, and we will show a image. Let's see if we get something good from this. Might take a minute to load. Okay, it doesn't like this here. Let's see if we can take the first image. Okay, here, so we get a 2. So if you're following along, you may get a different number than I did here. That's just the way that this was shuffled. But we do have a 2 here. So if we want to look at a different image, we can maybe look at one of the other batches. So you can kind of play around with this, but these are basically the images that you're dealing with. So we've got a 28 by 28 grid here. And so this is easy for us to visualize, but really when you train all of your data, you're going to be seeing tensors. But to us, all those zeros and ones are kind of confusing to like visualize. So if we plot it into a heat map right here or a color map, then we'll be able to visualize, hey, this is a 2. So this is a good way to kind of visualize images if you're dealing with images. So that's all I have for today. Hopefully in one of the later tutorials, I will be able to show you guys how we can work a little bit more with this data. So thanks for joining.